everyone, welcome back to my channel. If you're new here, please consider liking and subscribing, and if you already are subscribed, thank you so much. Today I just wanted to share a brief presentation on exactly how you go from CAD to CAM to actually cutting on a CNC. When I was first getting started on operating a CNC or looking into it, I feel like there wasn't a succinct video about really how to do that full process. So without further ado, let's get into it. Step number one is to have a design that you want to cut. I am going to show a very quick, simple example of designing something in CAD, which is computer-aided design, and the software that I am using is called Fusion 360. We're going to make a circle, and that's going to begin with creating a sketch in Fusion. We'll do a circle, boop, boop. Let's make this 3 inches. Okay, finish sketch. Now that we have our sketch, we're going to extrude it. And this needs to be equal to the stock width. So the material that I'm actually going to be cutting this out of, which I know is 18.35 millimeters. Okay, so now we're done with that. We'll go to the manufacturing environment. And that is where we are going to enter our CAM section. Wow! All right, manufacturing environment. So the CAM section is where we are going to define our tool paths, and we are going to put our design into pretty much a language that our router can understand. So I'm going to begin by creating a new setup. I apologize in advance. I work at my parents' and they are having a bunch of work done on their house, so there is a lot of power tool type noises in all of my videos. But anyway, there are a couple of important settings on the setup page, one of them being the work coordinate system. So this is pretty much the link between your model placement and the placement on the actual stock, which is the material that you have on your CNC bed that you will be cutting into. An important thing to note here is that I actually have my bit zeroed at my spoil boards. So I need to make sure that my stock setup matches that. And then I also need to make sure that my X and Y axis are the correct orientation. So I will show you what I mean by that. So we'll go over to my machine, and I will show you. One thing that I really like to do is to actually mark the point that I will be setting my zeros at. So this is where I'm going to zero my bit, and that is also the stock point that I just showed you guys. So on my computer, you could see that positive X was going this way, and negative Y was going that way. This is going to result in my model being, I don't know, something like that. Hopefully this makes sense. Sorry, my CNC is at like a weird, it's in a weird position, so the coordinate system is kind of confusing because we're looking at it upside down, but yeah. Hopefully that made enough sense. So now that we have that selected, we can add offsets if we want. I don't think that I am going to add any. I'm still trying to make sure that I understand what exactly is going on with these, especially for the top offset, so I'm not the person to go to with your questions on that. But we're going to hit OK, and now we are going to make our tool path. So I just want to cut this circle out. I'm going to go to 2D contour, I'm going to select the edge. Make sure you select the bottom edge because that's actually where we're cutting to. This would be the top of the stock, which isn't helpful. So I now have my toolpath selected. I'm gonna make sure that I have some tabs in here. And then the tool. Sometimes the numbers don't quite match up. So you can see on my bit, it is 425CM250CB. That's not in the library, but I think that as long as you have the appropriate diameter and, flute length and number of flutes and that kind of thing, it should be okay. We will choose that, select. Coolant. I have a spindle chiller, so I'm going to select flood. And in general, Fusion's pretty good at deciding your feeds and speeds for you, so I don't really mess with that. Honestly, I would leave it alone if you're just getting started. It'll probably be fine. The retraction height and the clearance height, those are just to make sure that you don't hit anything. Since I don't have any work holding items that are above my stock, I'm not really concerned. We are on the passes tab, so I believe right is conventional milling, and I've heard that that's recommended for the compression bits, so that's what I've been doing. Make sure that you change the multiple depths. I honestly don't understand why the default is just, oh, well, just cut the full thing in one pass. I feel like no one does that, so someone explain me why that's the default. So I think I'm gonna go for 6mm, and then the linking tab, I'm going to avoid ramping. I tried it out because that was also recommended for the compression bit, but I think that I actually get a better cut when I do not do that. So if you're just getting into CNC-ing, I would just worry about your tool. I would, do your geometry, something simple. The tab width and tab height I'm still messing around with, but I believe that that's preset as well when you just begin. Tab positioning, you can add your own tabs. Heights, make sure that you're not going to crash into your work holding. That wouldn't be great. And then passes. The only thing you should really have to adjust is the multiple depths, just to make sure that your bit doesn't go through the entire piece in one go. That wouldn't be great. That puts a lot of stress on that bit. And usually I think the maximum roughing step down is a lot less than 6mm, so if you're just beginning and you have, say, an upcut bit, I would do like 3mm, 2 or 3. Just do something not too dramatic to get started. If you're just getting a feel for your machine, we don't want to really test our limits. Okay, that should be it. So now the computer's thinking, it's going to make our little path for us. Perf. Okay, and then we also want to simulate with machine, get the little verification complete, make sure that that's looking how we want it. We see all of our tabs, we see that we're cutting all the way through our stock. Perfect. Okay, now we are transforming from the cam section to the cut section. So, in order to get this into a format that the machine understands, I forget what kind of file it is right now, maybe like a .3mf, but we need to make it into a NC file, which is numerical control. So Fusion is nice because the post-process right here will do that for us. Make sure that you have the right post-processor selected. So I have a Shapeoko. I'm going to make sure that I have my Carbide 3D post-processor selected. And then you can name it whatever. Make sure that you are saving it to an output folder that you want to be saving it to. I'm going to make a new one. New. We'll call it tutorial for YouTube. Okay. Select folder. And then I just keep document units the same, blah, blah, blah. I don't mess with any of this. And then I'm just going to hit post. Okay, so I have my file saved to the network now, and it's time to turn on my machine. This is Carbide Motion. I found that it works pretty well for loading files, and this is just free, provided by Shapeoko tutorial. So it's really nice having a network that I can save my computer files and then access them on this tablet, so I don't have to use my laptop for everything. So I will open this, open my file. So it's always nice to make sure that this is exactly what we want, so we can see. So I believe that's Y, that's X, so we're going positive X, negative Y, and our 0 is at the bottom, just like we wanted. So positive X, negative Y should cut this out approximately. All right, that looks good. I need to make sure that I have my X and Y axis zeroed at the coordinate system points that I have on the CAD or the CAM model. And so remember, on the CAM model, I chose a work coordinate system point, and I want to make this point on my stock reflect that one so that I know it's going to cut this way, not over here or over here. So my Z is zeroed on the spoil board, so I don't need to adjust that at all. But for the X and Y, I'm going to put the bit directly over that dot that I made and zero those. So it should then have the same work coordinate system as my computer CAM model. So there's definitely, well, there's probably a better way to do this, but I like to take the dust boot off so that I can see exactly where the bit is at. And then I move, whoops, I move my, I forget what you call that, like the carriage, I think. I move my carriage over. And then I'm not setting the Z0, so I bring the bit down on the Z-axis as if I was going to set the Z-axis 0, but that's just to help me line up with that point that I've marked out for the X and Y. So since I have my Z-axis 0 on my machine, zeroed at my spoil board, I'm not messing with that again for the foreseeable future, because whatever stock that I add, whatever width it is, I can control or I accommodate for that within my CAD. That's how I've been doing it recently. So if I get a piece of hardwood that's, say, 1 inch, I'm not changing the Z-axis 0 on my machine still. It doesn't matter the thickness of the stock when I have my Z-axis zeroed at the spoil board. So in order to accommodate for that, if I have a 1 inch thick piece of stock, I'm just going to change my CAD model and extrude that 1 inch, because that just tells my machine this is 1 inch thick, but I don't have to reset this because it's going to be 1 inch above where I have it zeroed, which is the bottom. I actually just zeroed on the spoil boards. It's been going well so far. I think I still have a lot to learn about the best way to zero things and adding like top and bottom, probably not bottom offsets, but like top offsets and all that, because it's not perfect, but getting there. So that's helpful, I think. I like having it zeroed on the spoil boards right now, for now. So that being said, much ado about nothing. Okay, we're going to move. We're going to move everything to that point. Make sure I don't knock my camera over. Whatever, that's probably good enough. Start. So the first thing that's going to do is come over to the bit setter. It's going to make sure. Nope, it's going to tell me to insert one, which I have inserted. Now it's going to go to the bit setter, and it's going to make sure it understands how long the bit is. And then the spindle has started, and it should start cutting in a couple seconds. What a racket. Ugh. I'm going to move this over just so we can see the cut better. But here it is. Just like we thought it would be. Circle. I have my phone flashlight so that you can see the tabs. So this is what I've been doing. I'm sure if you know a better way, please let me know. I don't want to undo all of my work holding just to get a piece out, which I'm sure when I'm cutting large projects, it won't be as much of an issue because I'll have used up all of my material and I'm going to need to switch materials anyway. But right now, it takes a lot of time just to get all of this off and reset it. So I did get a decent amount of tear out, unfortunately, on the top. And yeah, I guess on the bottom as well. So I'll play around with some settings and see. Maybe I need to increase the amount on the maximum roughing pass. Okay, so there you have it. We did the CAD, and then the cam, and then the cut. So hopefully that sets you up pretty well to know exactly how CNCs work, maybe gives you inspiration to pull the trigger and buy one for yourself, or just to get into learning CAD. CAD's really fun, 3D printing's fun, so yeah, you can do it. I think it sounds a lot scarier than it really is, and if you have patience and a willingness to learn, you will do great. So thank you for joining me. This was just a really short summary of that whole process, so if you're interested in seeing a particular part or a more in-depth description, please let me know and I can do my best. I'm also creating products for my business, ARO Designs, so I try to fit videos in when I can, but since I quit my job like 9 months ago, I'm running a little bit out of money, so I need to make sure that I am staying for the most part on track. But videos are really fun, so let me know. All right. Also, if you're not subscribed, maybe you could subscribe and like this video if you want to. It means a lot to me, and whenever I see a little notification pop up on my phone, it makes my little heart sing. So, I don't know, do whatever you would like to do. But I hope this was helpful, and yeah, thanks for watching. Okay, bye! Once I have my bit, so since I have my bit zeroed on the, so since I have my bit, so since I have, and my machine will know I've got to cut down 1 inch, and it will I don't know, it understands somehow.